You know, we all see solar panels as this amazing symbol of clean energy. And they are. But for firefighters, they can create a hidden, high voltage nightmare. See, during a fire, you can't just flip a breaker and make a solar array safe. That's exactly why a critical safety rule called rapid shutdown was created. Today, we're going to break down what it is and why it's an absolute lifesaver. Okay, so let's put ourselves right in a firefighter's boots for a second. A building's on fire, and you have to get on the roof to cut ventilation holes. It's a totally critical step to save the building and the people inside. Now, your first move is always to kill the main power, but with solar panels like you see here, that's just not enough. The danger is still very much alive up there. And this quote from Ken Willett at the National Fire Protection Association really hits the nail on the head. He says there is a possibility of electric shock because the electricity to the panels can't be shut off. As long as the sun is shining, or heck, even if it's just daylight, those photovoltaic panels are generating dangerous high-voltage DC electricity. You just can't put an off switch on the sun.
This leads to what's known as the persistent power problem. Firefighters can cut the building off from the grid, no problem. But the panels themselves and all the wiring running across that roof and down to the inverter, it's all still live. It's a completely invisible hazard that can be absolutely lethal.
And listen, this is not just some theoretical what-if scenario. It's a real-world problem. Just take a look at this major fire that happened at an office building in Wisconsin. The roof was covered in solar panels, and because of that, it was nearly impossible for the firefighters to do their job and ventilate the roof. They had to fight the fire from the ground, which really held them back and led to huge damage. It's the perfect example of what can happen when our technology moves faster than our safety rule.
So this growing danger really demanded a solution. The people who write our electrical codes had to step in and find a way to protect our first responders. And that led them to create a brand new safety mandate. The solution has a name. Article 690.12 of the 2017 Philippine Electrical Code. Now, this wasn't just some small update to an old rule. Nope, this was a completely new section, written from scratch to solve this very specific problem. It mandated something called rapid shutdown, and it had one very, very clear goal: keep firefighters safe.
10 seconds. That's it. That is the critical time limit the code puts on this system. From the exact moment a firefighter hits that shutdown switch, the system has just 10 seconds to de-energize those high-voltage wires. In an emergency, where every single moment counts, that strict time frame is literally the difference between a safe roof and a deadly one.
And things moved fast. The code was published in November of 2017, and just a few weeks later, on December 2nd, it became law. From that day on, rapid shutdown wasn't just a good idea. It became a mandatory safety feature for new rooftop solar installations.
So the big question is, how does this system actually work? How does it make a rooftop safe in an emergency? Well, the concept is pretty straightforward, but the engineering behind it is actually what makes it so incredibly effective.
All right, let's take a look at this diagram to see the nuts and bolts. You've got your PV panels on the left, making power. That power flows down to the inverter to get converted for the building to use. But the real life-saving parts here are the rapid shutdown control and those DC-rated relays. You can think of them as the brains and the muscle of the whole safety system, and they're put in just the right spots to cut off that dangerous voltage right at the source. So what exactly is a rapid shutdown system, or RSD? Well, at its heart, it's an emergency brake for a solar panel system. It's a safety device designed specifically to de-energize those high-voltage DC wires coming from the solar array. Its entire reason for being is to get rid of, or at least drastically reduce, the shock hazard for anyone who has to be on that roof in an emergency. The real magic happens with these little things called DC-rated relays. They're basically remote-controlled switches placed right up near the solar panels. A first responder activates them by hitting a single control button, usually a big, obvious red button. The code is really clear that this button has to be installed somewhere they can find it easily, like right next to the main electrical panel. When they push it, a signal shoots up to those relays, they snap open, and just like that, the flow of high-voltage power is cut off. This slide really shows you the night and day difference. On the left, without the system, you've got wires running all over the roof carrying hundreds of volts, totally lethal. But on the right, once that button is pushed, the system creates what the code calls a safe boundary. And the code is super specific about this. Within that 10-second window, any wire outside of this boundary, so more than a foot away from the array, has to drop to below 30 volts. And even the wires inside that boundary have to drop to below 80 volts. That reduces the danger from lethal to manageable, and it's what allows firefighters to get up there and do their job safe. So what's the big takeaway here? It's so important to understand the real-world impact of this code. This isn't just some tiny technical update. It's a fundamental shift in how we think about the safety of solar power.
And the benefits are just so clear. For firefighters, it's a total game changer. It gives them the confidence to get on a roof and do their job without fear of electrocution. For the installers, it sets a new, higher standard, making safety a core part of the design from day one. And for building owners, it gives you peace of mind knowing that your clean energy system isn't going to put the people who protect us in harm's way.
You know, the story of rapid shutdown is really a fantastic example of our safety rules evolving to keep up with our technology. And it leaves us with a really important question to think about. As we keep innovating and finding new ways to power our world, how do we make sure our safety codes are always adapting to protect the people who are out there on the front lines protecting us?